I'll just run through this. No. 30 seconds about what I'm doing. I've been in networking since 1985 or so, so I started like all the really old people with X25 and DECnet, and discovered IP later on after I got sick and tired of Novella IPX, if anyone remembers that. Then I wrote a few books for Cisco, developed a few courses, and in the last years, I'm primarily blogging, doing my own webinars, focusing on new and emerging technologies like data centers, virtualization, and cloud computing, which is what I'll be talking about today. Number one, I'm never talking about futures, I'm talking about features. So what you will hear about today is what's currently available, okay? And I will mention a number of companies, and it's not bashing, it's not endorsement. I'm not saying that what they do is good or bad. I'm just telling you what architectural choices they have made and how that may impact the scalability of your solution. And the real question, the one that I'm asking for the last 2 years, does it scale? And we all know that VLANs don't scale, although some vendors are trying to persuade you otherwise. So, you know that when we talk about cloud services, it means 300 different things to 100 different people. And just to make sure that we are all on the same page, this is how I understand different cloud services, from software as a service, which is really someone accessing a website, but now it's called software as a service, down to server virtualization, which is called infrastructure as a service. And then you have database as a service, and storage as a service, and DNS as a service, for example. And most of those things are just plain boring if you're a networking person, because they all run on TCP. How is that different from good old days? It's not. So everything else but infrastructure as a service is plain boring. We know how to run IP because, well, after all, we built the internet. We know how TCP works. Well, we should. If you're really interested in how you can build really high-speed data center networks, I have another session tomorrow where I'll talk about cross fabrics and what we can learn from the voice guys, what they discovered 60 years ago. Anyway, so this is the thing that we will really focus on today, because this is the only thing that's interesting. And we've been doing server virtualization for 6-7 years now. So why am I talking to you right now? The problem is that the moment you move into the cloud, everyone thinks that this thing is infinitely scalable. Well, it's not infinitely scalable even if you're Amazon, as they proved a year or so ago. It should be elastic, which means that as an individual, you should grow up and down as quickly as you wish, which yet again may not be true, because even on Amazon, you can't spin up the virtual machines quickly enough. It always takes time to spin up a virtual machine. So there are people that made huge science out of predicting what their load will be, just so that they will spin up the virtual machines just in time. And there are articles being written about that. And everything should be on demand, and everything should be orchestrated and customer-driven through something like a web portal on Amazon. And that's what makes this thing really interesting. Other than this, it's boring stuff like server virtualization has been boring for the last 6 years. The first thing that you have to ask yourself, by the way, is, why am I doing this? Why am I even considering cloud services? If you're a service provider, you should ask the question, what is my added value? Why would someone buy from me and not from Amazon? Because, well, they scale better. They will always be cheaper. You can't be cheaper than Amazon. Well, you can, but not if you want to make some profit. So what is your added value? It might be that you're local. It might be that the data is actually in Poland, which might matter. It might be that US government can't get to your data because you are not under Patriot Act like Amazon is. So there are all sorts of different reasons, but you have to know what you're doing. Saying, I will be like Amazon, is plain stupid. You have to be different. And then you have to ask yourself, what is my focus? Amazon is clearly focused on new applications. If you want to move your existing badly designed enterprise application into Amazon Cloud, they will tell you to go away. They don't care. They have enough Netflixes out there willing to spin up thousands of virtual machines. They will not implement IP multicast just so you could run a cluster between two Linux servers. Either you do it properly with load balancing, or you can go somewhere else. Okay? And I've seen a lot of people who think that their added value is supporting old stupidities. So there are people out there who think that you have to implement layer 2 networking just so people could run multicast. Well, how many applications actually need multicast? Apart from brokers. Brokers and stock exchanges are different planet. IPTV is a different planet. For enterprise applications, how many of you have actually seen an enterprise application using multicast? One. Okay. Two. Good. Huh? Yeah. Okay, that's a good one. I haven't heard that one before. But that was in US, right? Okay. Good. So you have to ask yourself, will you be like Amazon? Will you be low cost? And what is your added value there? Or will you be feature rich? And then you have all sorts of complexities. For example, Amazon made a very simple decision. Someone wrote a really good blog post a while ago saying, do you want to be a TCP cloud or a UDP cloud? And VMware claims to be a TCP cloud. They have high availability. If a server fails, they will automatically restart a virtual machine on another server. Okay? What they forget to tell you is the keyword, which is restart. A server fails, the virtual machine fails, it is restarted, yeah? How long does that take? 5 minutes? 10 minutes? 15 minutes? How many nines have you just lost? Because the VM was restarted. Okay? Anyway, they call what they do, well, it's an unofficial term, of course. I've taken that out of a blog post, TCP cloud, because it's sort of reliable. Whereas Amazon is clearly a UDP cloud. Amazon doesn't guarantee you anything. When they do server maintenance, they just shut down your VMs. They don't care. Spin them up on another server. Ah, you don't use load balancing. Too bad. We told you to use load balancing. Okay? So Amazon is typically a low-cost UDP cloud. Do they support IP multicast? Of course not. Why? Because it doesn't scale. You want to have hundreds of thousands of servers and millions of virtual machines, and you want to keep the SG state for that? Are you out of your mind? It doesn't scale. So forget about IP multicast support if you're Amazon. Yes, if the application supports it, right? Yeah. Anyway, Amazon very clearly decided that they don't want to support IP multicast because the incremental business they could gain is not big enough to warrant all the complexities. Okay? So you have to decide where you want to be. And then there is something I call infrastructure as a service light. And this is how OpenStack works today, sort of. And this is how Amazon worked in the good old days before they implemented the virtual private cloud. So what you do is you just start the VMs. You assign them to whatever subnet happens to be there. So they get random IP addresses. And then you pretend that you solved the tenant isolation with packet filters. So if tenant A has no way to get to tenant B because they're both on the same subnet, and the packet filters are blocking the intra-subnet traffic, you're sort of OK, right? Of course, your VM1 has problems talking to your VM2. That's a different problem. So this is what Amazon was doing in the old days. And this is really very simple to implement. Not with VMware, because VMware doesn't run Linux. Well, it does run Linux kernel, but it's so well hidden that you can't get there. On something like Xen or KVM, you just use IP tables, and you have your packet filters. With Xen and Open vSwitch, you can actually use OpenFlow to download packet filters from the central management server into the Open vSwitches where the VMs run. If you're in VMware environment, use private VLANs like you would in the physical world. They sort of work with VMware's VDS. They actually work with Nexus 1000V. So you could use those. Or there's another option with VMware. You could use the virtual firewalls, which is another great concept. So inside each server, you run an additional virtual machine that serves as a firewall for all the other virtual machines running on the server. Okay? Now, the only problem in double quotes is the performance. Because the way VMware does that, they consume 1 core, and they give you 4 gig. Not a good idea. Juniper, with their virtual gateway, is actually way better, because they do the filtering not in the virtual machine, but in the kernel. And they're able to get to something like 30 or 40 gig, and they only consume 20% more CPU. It's still a lot, but I mean, honestly, how many people are pushing 30 or 40 gig out of a multi-tenant hypervisor server? No one is. And Cisco has a really interesting thing. The virtual firewalls are somewhere outside, but you can use service insertion with Nexus 1000V to push the traffic to the outside firewall and then back. Okay? Scalability of this thing is unlimited, because this is exactly how we build the internet. Replace these virtual machines with your home users. Okay? Each home user has a small firewall in front of him. It's called NAT. And some people still think NAT is a security feature, but I'll not go there. So this is how we built the internet in the first place. So this thing definitely scales. It's been proven to scale very, very well. Unfortunately, this is not what the customers want. So some customers actually, when forced to use something like this, start to build their own layer 2 private networks on top of the IP infrastructure that the cloud provider gives them. And there are companies that make business out of the inability of cloud providers to give the customers the virtual networks. One of them is vCider. The other one is CloudSwitch. vCider allows you to build a user space. Well, the virtual machine space is more precise. Layer 2 network. So they have their own device driver, which appears as Ethernet, but actually does MAC into IP encapsulation. and sends that out. So you can build a layer 2 network over IP. And the beauty of their solution, I mean, they call it a beauty, I disagree, is that you could have virtual machines in the same IP subnet, half of them running at Amazon and half of them running at Rackspace or your home network. Now, I personally don't think it's a good idea to have a layer 2 subnet that is that long. But some people just believe that Earth is flat, OK? So you can do that if you wish. And if you need to connect virtual machines in different clouds, now why would I ever want to do that? I have no idea. But if you want to, you can do that with a solution like this. Now, what actually the users want is they want to have an application infrastructure like they used to have in their private networks. So logical segments, separated with firewalls, load balancers, packet filters, web servers, app servers, database servers, routing or load balancing or firewalling between them. And usually, you're limited to one interface per VM, which, by the way, nicely stops the stupidities like a customer configuring bridging between two NICs, which people have been known to be doing. I was actually in California, and it was late evening, and there was this poor guy from Australia standing next to me. He got a phone call because, you know, they were running. Well, it was a prime time in Australia in that time. And what someone did in his cloud, he actually had a Windows VM with two NICs and bridged them together. And the moment you start doing that, Windows starts sending out STP packets, and they hit BPDU guard on the upstream switches, and everything was offline. Okay? So a while ago, I had a discussion whether, you know, a virtual machine can actually bring the whole hypervisor server offline. Yes, it can. A few days ago, I got a desperate tweet from him saying, now I've spent the whole weekend debugging a customer problem because now he extended that layer 2 network to another location. So try to limit your customers to one NIC per VM. And of course, everyone wants unlimited scalability and mobility, and everyone wants to have layer 2. No one can tell you why they actually need layer 2 because every application runs on IP these days, right? It's not like we would have AppleTalk printers. But everyone wants to have layer 2. And everyone wants to have flooding. Why? Well, because that's how we always did things, right? They can't tell you why they need it, but they want it. And there's a whole space of solutions. And by the way, this is not up to scale. I mean, if this scalability thing would be up to scale, you wouldn't see the top part, because it would be so narrow. VLANs that we all love to hate can go up to 4,000 segments. Now, with the application architecture I've shown you before, that's like 1,000 users, right? Yeah, that's scalable cloud. You'll earn a lot of money with that. So that's out of question. The other problem with VLANs is that, you know, because you never know how the VMs will move, people tend to provision every VLAN on every port toward every server. And that definitely doesn't scale because you've just turned your whole network into a single failure domain. That's a good idea. So emerging things like edge virtual bridging, which, by the way, is a technology I hoped will die, but it refuses to die. And now IBM has implemented it in their, what's that thing called? Some virtual switch 5000V or something. So it must be five times better than Nexus 1000V, right? So now they have a virtual switch that sits inside VMware and actually does EVB. EVB is actually not a bad idea if you want to stay with VLANs. And you could combine it theoretically with provider backbone bridging or SPB that Peter is describing in the next hall. And you could get things that scale way better than VLANs. But it's still layer 2. VMware was faced with a particular problem 2 years ago or so. There was this other consortium of companies, like 3 of them, that put together a prepackaged compute storage offering that you could buy called vBlock. And that thing was great, but it only supported 256 VLANs or something at that time. At that time, I said. So that's a problem, right? You have this huge amount of CPU cores, and you can support like 60 tenants on it. Doesn't feel right. So they figured out that they just happen to have this old acquisition called Lab Manager. So if we tweak this around and we put a new GUI in front of it, now we have a virtual cloud director networking infrastructure solution, which is Mac in Mac, but it does go way beyond the VLAN limitation. So it's still bridging. It still doesn't scale well, but at least you're not limited by the number of VLANs. Finally, people have realized that, well, bridging doesn't scale. Well, some of us have known that for the last 20 years because we've been burned 20 years ago. Some other people have realized this recently. Anyway, now you have like 3 totally different proposals how to do bridging over IP. Cisco and VMware have VXLAN. Microsoft and HP, of course, couldn't stay silent, so they launched NVGRE a week after VXLAN was launched. And Nicira has been doing layer 2 over GRE for quite a while, and now that thing is called Open vSwitch, by the way, and runs in Xen, and now it's part of standard Xen distribution, so you get it with Xen. And now they have a really nice control plane. And Amazon has realized that, you know, bridging doesn't scale when they started. So they were always doing IP over IP. I mean, it's not official. You will not find this anywhere. But if you just start a VM instance on Amazon, and you put a few instances in your private network, and you look at the ARP tables, you see that all of them have the same MAC address. Tells you a lot. OK? Now, there are like 3 distinct architectural models I've mentioned in the previous slide. The first one, called VLANs, is we have a stupid edge and a stupid core. And that reminds me of the very old voice switches where poor ladies were doing patch cables. And the only intelligence was on the left-hand side of the picture. OK? Now, we're moving away from that toward VM-aware networking and EVB, which is stupid edge because the hypervisor switch is still stupid, but smart core. And if anyone has ever seen ATM networks, you know what I'm talking about. And what RFC 1925 has to say about that is, with sufficient trust, pigs fly just fine. And what Randy Bush had to add was, well, you know, but can you pay for the fuel? And by the way, do you really want to see pigs flying? The only scalable thing is smart edge with simple core. I mean, just remember the voice switches, those huge boxes that could switch like maybe a gigabit. And they consumed something like this room. And you couldn't get them smaller because all the state was in the switches. and compare that to a pizza box switch that actually routes IP and has a terabit of bandwidth because it has no state. And voice really got, well, not simple, cheap. It's not simple. It got cheap when we moved to voice over IP because we moved the complexity and the intelligence to the edge, and the core is pure IP forwarding. The same thing has to happen in virtual networks. It has started with VXLAN from Cisco and Nicira and Amazon. And by the way, there was this RFC written years ago saying you should design protocols in a way where the core has no state. And hypervisor vendors have successfully been ignoring this for the last 10 years. So, yes, if you want to build layer 2 solutions, you can still build them. And Cisco with Fabric Path can easily do designs that go to tens of thousands of ports. I've seen a design that went to 18,000 something ports. No one wanted to say that you can run layer 2 over that, which was OK. But you could if you wish. Arista with 2 core switches, because they have these gigantic core switches, could go to 1,900 ports on layer 2. Juniper with QFabric theoretically can go to 6,000 ports on layer 2. But let's do now some reality checks. Yes, you need layer 2 VLANs because of vMotion, right? That's what every server guy is telling you. I really need layer 2 because I want to move my VMs. Yeah. Now, VMware has this thing called distributed vSwitch. It can run on 350 servers. And you can't vMotion out of a VDS. So your vMotion domain is 300 servers, which is 600 ports with dual uplinks. That's about the maximum size that makes sort of sense. Everything beyond that is, plain stupid. And Nexus 1000B currently supports like 64 hosts. And I think that's going to change. They were already talking about that. And by the way, as the guys in the next room will hear, spanning tree is gone. Okay? We have Trill, we have SPB, we have Fabric Path, we have whatever from whichever vendor. Yes, we can get rid of spanning tree, no problem. You cannot get rid of broadcasts. You cannot get rid of flooding. I mean, spanning tree is so stupid that thank God it's gone. But broadcast will still kill you eventually. Okay? And by the way, people don't realize that a layer 2 network is a single failure domain. You just need one VM to go crazy, or one VM to bridge 2 segments, and you're dead. So having a huge layer 2 failure domain does not make much sense. This is how VXLAN looks from the architectural perspective. So you have what looks like layer 2 switches. Effectively, they get encapsulated in VXLAN packets, which get encapsulated into UDP packets, which get encapsulated into IP, and then they are sent as IP packets across the network. VXLAN has 2 small problems. One is that, as I told you, Nexus 1000V on which it is running can only support 64 hosts at the moment. So it's a great solution if you want to have a cluster that is spread across 2 rows. Okay? A VMware cluster, by the way, can have how many hosts? 32. 350 is the virtual distributed switch. So 32 hosts in a cluster, Nexus 1000B running on that cluster, 16 hosts in one row, 16 hosts in another row, and you have IP in the middle, so the bridging failure domain is limited. Makes perfect sense. The only problem is that VXLAN does not have a control plane. There is nothing that would learn where the MAC addresses are and tell other hypervisor hosts where those MAC addresses are. VXLAN is bridging over IP. It uses flooding to dynamically learn the MAC addresses. By the way, that also allows you to spoof any MAC address you wish. If you have access to VXLAN core network, you can just insert any packet into any VXLAN segment using any source MAC address to attract any traffic you wish. Isn't that cool? So, protect your IP core. This thing in the middle has to be absolutely protected. Okay? Now, the other problem is that because they need flooding, they did the right thing. They said, we don't want to have source-based flooding or head-end replication. We'll use multicast. So, those of you who had to configure multicast on your CCIE lab exams, now you know why you will need that. So this will be like the first multicast application ever in an enterprise network that I will see. But the problem with multicast is that eventually you get enormous amount of SG state. And not every data center switch supports millions of SG entries. Now, some switches that I've been mentioning before support like 4,000 SG entries. And if you want to know which company it is, just go through the data sheets. So, dynamic MAC learning through flooding does not scale. It scales better than other things, but still, it's not infinitely scalable. So what Nicira is doing is they went one step further. They said, we want to have a proper control plane. We know where each VM is sitting. We know which MAC address each VM has, because after all, that's assigned by Zen. We can even figure out which IP address each VM is using, because we can look at the packets, because actually we're forwarding them. So when we start a new VM, we don't want to use flooding for everyone else to learn that. We could actually go and program the hypervisor switches correctly through a control plane. So it's almost like you would have in an MPLS VPN world the PE routers sitting in the hypervisor switches, only they're not running MPBGP. They're running something called OpenFlow, which you would almost have seen a demo of. So what they're doing is they're capturing the initial packets, like the ARP request from the virtual machines, figuring out which MAC address and which IP address the virtual machines are using, and distributing that to all the other hypervisor hosts, to all the other Open switches that belong to the same virtual network. So you have the proper control plane. You don't need flooding. And by the way, they still need flooding, because there might be some stupid applications that actually need flooding in layer 2. And they said, well, we'll give you two options. Option number 1, we could do head-end replication. Option number 2, you could deploy something special in the network called pool node. And that thing in the middle of the network could do the unicast replication that would emulate flooding. Now, is anyone old enough to remember broadcast an unknown server in ATM Lenny? That's the same thing, reinvented. The other thing they're also doing, and this is really cool, because they know who has which IP and MAC address, they could turn an ARP request into a unicast. So I'm sending out a broadcast ARP request, but because the virtual switch knows where the destination is, it would turn that into a unicast, and it would only land at the proper virtual machine. So here is a comparison of what is more or less scalable. So VLANs are the worst possible solution, and Amazon EC2 is the best one, but, well, no one has replicated that outside of Amazon yet. Now, does it matter? Actually, if you have a few hundred servers and a few hundred users, it doesn't. Use VLANs. As stupid as that sounds, they are simple. So if you're small, use VLANs. If you still have a few hundred servers, which is the size where broadcasts don't matter much yet, and you have thousands of tenants, each with a few virtual machines, use something like vCDNI or Q-in-Q. If you go beyond that, VM-aware networking like Arista is doing, or Cisco with VMFX, or Juniper with Juno Space, whatever, virtual control, or NEC with their OpenFlow controller, this might be a solution. If you go beyond that, use MAC over IP. And if you want huge scale, use Nicira's IP, layer 2 over IP with control plane. And by the way, don't forget, you can always split your data center into multiple availability zones and get a bit more out of it. And now, because they told me I have like 3 seconds, I will skip this one. I will skip this one, which tells you how we can help you. So you know where to find me. And if you have any questions, now it's time for questions.
Okay, don't you think that Nicira solution has the same scalability problem in the control plane when you need 4 million of MAC to IP mappings, as we discussed for Lisp, for example?
No, because with Nicira's solution, every Open vSwitch only has the mappings it needs to support the VMs running on it. So worst case, you have like, usually people would have something between 20:1 to 50:1 virtualization ratio. So if you have 50 virtual machines on a hypervisor host, and worst case, every machine is in a different virtual network, and worst case, you have like 100 virtual machines in every one of those networks, the Open vSwitch would have 5,000 entries. Control plane is a different story, and what they're doing there is they have a clustering solution where you can just scale out. You can add controllers to the cluster, and different hypervisor hosts would connect to different controllers in the same cluster. And in the back end, they have whatever distributed algorithm to distribute state between the controllers. I mean, there are people, you see, the problem is that the programmers got really, some programmers got really good programming distributed systems when we weren't looking. So now they are applying that knowledge to the controllers. I mean, if Facebook, for example, can serve billions of users using their infrastructure, it's obvious someone could build a controller that could serve hundreds of thousands of hosts. Okay? So yes, they have a scale-out architecture. The trick is that those mappings are not in the data plane. They are in the control plane. Well, actually, they are in a database somewhere. Yeah. Well, yeah. Theoretically in the control plane, but in the database. And if you have a UDP cloud where you don't have the stupid idea that you have to move the virtual machines here and there, then the only events are VM spin up and spin down. So there are not that many events. Okay? Any more questions? This was a great one. Thank you.
I'm afraid we don't have more time for...
Okay, so you'll find me outside or during the party. Just find me out.